So now we are going to discuss about incidence matrix. Okay, the question asked in November December 2023. The oriented graph of a network is shown in the figure. So this was given, okay, in the question paper. You need to obtain the incidence matrix. It is very simple to write the incidence matrix. So listen carefully. So here there's 1, 2, 3, 4, 5, 6. These are all nodes. So always we need to write the nodes here, okay, as a row of a matrix. Okay, row represent the nodes and column represent the branches. Okay, row represent the nodes, column represent the branches. Here AI is my incidence matrix. So listen carefully, it is very simple. See here, if you take a branch A, so it is connecting node 1 and node 2. It is incident on node 1 and node 2. Okay, so see the direction. So if it is going away from the node 1, I need to put 1 here. For branch A, it is leaving the node 1, so I will be putting 1. It is entering the node 2, I will be putting -1. If it is incident at the node, it should be -1. If it is going away, we need to write +1. Okay, if it is going away, I will be putting +1. If it is going towards, I will be putting -1. So remember that. Okay, so if you take branch B, it is going towards 3. It means for 3 it will be -1. For 3 it will be -1. It is going away from the 2, oriented away. I write it as oriented away, oriented towards. Okay, if it is oriented away, it will be +1. From 2 it is oriented away, so it is +1. So similarly we can write for all. For C branch, the C branch is here. It is oriented away from 3. So 3 will be +1. It is oriented towards 4. So 4 will be -1. Okay, so next D, if you see D, it is oriented away from 5. So 5 will be +1. Oriented towards 4, it will be -1. So similarly you can do for the remaining cases. And one more important thing here is, if I add the column, I will be getting 0. Each and every column, if you add separately, you will be getting 0. So that is the advantage of this incidence matrix. So we can verify the incidence matrix like that. Okay. So sometimes the graph may be given without any directions. If it is given without any direction, you can put your own directions. Okay, there is no problem with that. Okay, so don't expect the question will be like this in the same way. Sometimes the circuit will be given, you will be drawing a graph, and then you will be drawing a directions. Doesn't matter. So there is no rules for selecting the directions. So direction can be up to you. Okay, direction can be up to you. So this is what asked in the university question paper. Just there is one more thing called reduced incidence. Okay, that is not asked, but anyway I will teach it. So there is an advantage here. If I add each and every element in the column, I will be getting 0. So I will take that as an advantage here, and I can remove any of the rows. Okay, so because definitely I know that. So I will be adding all the elements in the row, in the column. If I didn't get 0, I will add -1 or +1 based on for which number is added. I am going to get 0. So if already there is a 0, I will be putting 0. Okay, while performing the addition, already if I get 0, I will put 0. If I get -1, I will put 1. If I get 1, I will be putting -1. Okay, so I can remove any one of the row. So here simply I can remove the 6th row, and I can have 5 rows in the reduced incidence matrix. Okay, so from the incidence matrix, without losing any information, I can draw the reduced incidence matrix. I will show that here. Okay, so here if you see, this is my incidence matrix which I found. So here what I am going to do is, I am going to remove the last row. I can easily reconstruct here. 1 -1, already 0. 1 -1, already 0. Okay, so I will be putting 0, 0. 1 -1, already 0. So I will put 0. 1 -1, already 0. So I will put 0. Here if I add all the things, I will be getting -1. How do I make it 0? By adding 1 here. So 1 -1 will be 0. Here if I add all the elements in the column F, so I will be getting 1. I need to, in order to make it 0, I need to put -1 here. So 0, 1. If I add all the elements here, I will be getting 1. So in order to make it 0, I will put -1. So here already 0, 1 minus 1 is 0, here also 1 minus 1 is 0. So now compare this to, both will be same. So this reduced incidence matrix is just remove any of the rows and construct the reduced incidence matrix. Okay, it is another concept which you might know, but it is not asked in the exam. And another 2 mark which is asked is the properties of the incidence matrix. Okay, the property is, if there are n nodes and b branches, then the order of the matrix will be n times b. Okay, you'll be getting n rows and b columns. That is the meaning here. N rows and b columns will get. Based on number of nodes, I will be deciding the number of rows. Based on number of branches, I can decide the number of columns. Next, algebraic sum of the column entries of the incidence matrix is 0. If I add each and every element in the column, I will be getting 0. So that is the advantage I used for writing the reduced incidence matrix. So determinant of the incidence matrix of a closed loop is 0. And then each row of the incidence matrix represents the corresponding node. Each row represents the node and each column represents a branch. So these were properties. So this also asked in the 2 mark. Okay, in the last arrear exam. Okay. Thank you.